Hello, welcome to class. Today, we're going to be looking at an important concept known as sorts. Now, I want you to note that sorts are a very important concept in mathematics. Then let's get into the lecture. Before we can understand vividly the concept of sorts, we need to first understand the difference between rational numbers and irrational numbers. Now, what are rational numbers? These are set of numbers that can be represented in the form a over b. Of course, where a and b are both integers and b is not equals to 0, meaning that rational numbers oftentimes can be represented in the fractional form. Example of rational numbers are 5 over 1, 1 over 2, 10 over 2, 2 over 7, and so on. And I want you to also note that we can say that the set of rational numbers are numbers that terminate after some terms. And if they do not terminate, they usually have what we call repeated block. Now, example, 1 over 2, you can see 1 over 2 equals to 0.5. It terminates. And then 1 over 4 equals to 0.25. It also terminates. Now, but if you look at this other number, 26 over 7, 26 over 7 in your calculator or computer will give you 3.714285. 714285. Now you can see that there are repeated blocks here. That is how it continues. So I want you to note that rational numbers are a set of numbers that if they do not terminate, they usually have what we call repeated block of numbers. For example, again, 1 over 11. If you see this, 1 over 11 gives us 0.09090909 and so on. You can see the repeated block 09, 09, 09, 09. So these are the repeated block. Another example of the rational numbers to help you understand this concept is 10 over 3. And 10 over 3 gives us what? 3.33333. Of course, you can predict the next numbers because it has what? Repeated block. I hope you understand this concept of rational numbers. Remember I said that before we can vividly understand the concept of sorts, we need to first establish or understand the difference between rational numbers and irrational numbers. Okay, now let's look at irrational numbers. Irrational numbers are a set of numbers that do not truncate or terminate, and then they also do not have what we call repeated block. That means the decimal continues indefinitely without recurring. For example, if you look at the number pi equals to 3.141592654 and so on. Now, if you study this number, this decimal number, it has no repeated block. So it means you cannot predict the next block of numbers. So it therefore means that pi is an irrational number. Another classical example is square root of 3. Square root of 3 is 1.732050 and so on. So it continues like that without a repeated block. Therefore, we say that square root of 3 is an irrational number. Another classical example is square root of 2. You can see the square root of 2, the value. There is no repeated block. So all these set of numbers are called what? Irrational numbers. Now, having understood what rational and irrational numbers are, let's look at the concept of sorts. What are sorts? We say sorts are simply irrational numbers which are in the form of roots. Sorts are simply what? Irrational numbers which are in the form of what? Roots. Example, square root of 2, square root of 3, square root of 5, square root of 7. All of these are irrational numbers in the form of roots. Therefore, we call them what? Sorts. I hope you understand this definition. Sorts are irrational numbers which are in the form of what? Roots. Now, I want you to note something. Square root of 4 is not a sort because square root of 4 is 2. And the answer we get here is a rational number. So we can't say that square root of 4 is a sort. Example again, square root of 9 is equals to 3. So it is not a sort. Square root of 16 is equals to 4. It's not a sort. So I want you to note, these are not sorts. Why? Because when we simplify them, we simply obtain what? Rational numbers. Okay. Let's look at some rules for simplifying sorts. some rules for simplifying sorts. Now, I want you to just copy down these rules because we're going to be applying them throughout our study of the concept of sorts. Now, the following are some of the basic rules that are commonly used when performing operations on sorts. Number one, the first rule is that square root of m times n is equals to square root of m times square root of n. That means we can split them. The second rule states that square root of m over n is equals to square root of m over square root of n. The third rule states that square root of m plus n is not equal to, that means it is not the same thing as square root of m plus square root of n. Please take note of this because many students make these mistakes here. Square root of m plus n is not the same thing as square root of m plus square root of n. Also, square root of m minus n is not the same thing as square root of m minus square root of n. Then the next law I want you to notice that a root m is equals to square root of a square root m. See what I mean? Square root of a, if you have a root m, now the rule says when you move this a, the number outside here, we're going to have something like this because we are working with square root. So once this a enters here, it becomes what? A square, then multiply by m. So take note of that rule. A root m is equals to what? Square root of a square times square root of what? M. Okay. Now, the next thing I want you to note is that a cube root of m, this is another rule, is equals to, because this is a cube root, so once we push this a in here, we have cube root of a raised to the power of 3 times what? M. So it therefore means that a, the nth root of m, will always be the nth root of a raised to the power of n times m. So these are the rules that we use in the study of sorts. But there's a condition here, that the condition is that provided m and n are positive numbers. Now, all these rules can be verified, but I will leave the verification for you to do them as a leisure work. Now, the leisure work here is verify the laws of this sort using the following values. So the numerical value here is, use the value of m equals to 9, n equals to 4, and a equals to 2. Just plug it into the rule and see if the left-hand side will give you the right-hand side. So if the left-hand side equals to the right-hand side, then that means these rules have been verified. Thank you so much for your attention. We've come to the end of this particular lecture. In our next lecture, we shall be considering the concept of simplification of sorts. See you in our next class. Thank you for your attention.